Hi. In this video, we're going to give you another examples of permutations of object with repeated object, right? Where there are some object are repeated. So look at this question here, arrangement, right? Arrangement. So we're going to see how many letters here are actually repeat. Okay. Then we try to answer the question one by one. And the first one is how many different arrangement if it begins with R and end with E. It must be begin with R and end with E. So before that, I should identify how many objects are actually repeated, right? So how many A's, how many R, and how many N, alright? So let's see, arrange A, you have how many A? 1, 2, 2A, right? 2A. So R, how many R? 1, 2. 2R. So followed by N. I think E, right? E is repeat. Oh, N also, right? N also repeat. So E you have 2, right? E, double E. So 2 repeat. So N you have 1, 2. I think the rest should not be repeated, right? So you see that A, N, okay, G, M, G, M, T and S is not repeated, they are single. So G, M, T and S, right? The rest will be repeat, double N, double E, double A, double R. Alright, I hope I'm not doing mistake. So there are total of how many? You calculate here how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total up here you have 8 plus 4, yes, 12 of them. So okay, let's start with the first question. So the first question is saying that A. So begins with R and end with E, alright? Means that you have 12 letters, right? You have 12 letters. So but it must be begin, okay? Begin with R and ends with the letter E, right? So means it's already fixed. What's the meaning here is that it must begin with R and end with E. Mesti mula dengan R dan E. Wajib, compulsory. So means that you still have how many letters, right? Total you have 12 letters, right? 12 letters. So in the middle here, you still have 10 letters, right? Means that we have 10 letters. Means we have chosen, okay? Means that the R have been chosen to be 1, right? Chosen 1, the 1 is putting here, right? The R is putting here. So, and E already chosen, means 1 is already fixed, it's in the position of the N, okay, the last location here. So R and E. So means that we still have 2 repeat and 2 repeated N, right? Because R is 2, E have 2, but because 1 is already putting in front and E is putting at the back, so you have only 1 left, right? So means that the one that repeat will be 2N and 2A. So means that in this calculation, the number of ways will be, you have not 12 factorial, because you no longer include the first and the last one, okay? It's already fixed. So means you just arrange the 10 factorial. Among the 10 alphabet left, only 2N and 2A. So I need to divide by 2 factorial and 2 factorial. That's all, right? So let's see what's the answer, right? Which we're giving you 907 200 ways, right? So means this is arrangement, whereas I exclude one of the R, right? Because one of the R already fixed, must be begin, and one of the E is already excluded, so means I have only 1 R and 1 E, and the remaining we have 10 more alphabet to be arranged in the middle, right? Now we no longer consider these 2 because it's fixed, right? Something is fixed, we don't consider. So then we have 10 more letters. So among the 10 letters, we have 2N and 2A. That's why I take the 10 factorial divided by 2N and 2A. Alright, so let's look at part B. Alright, okay, let's look at part B. So where the arrangement where the 2 letters E are separated. means that the two letter E are not together, right? They are separated. So how to calculate it, right? So of course I wanted to try first, right? You have to try first, and then you look at my solution. So usually you have how many letters here? You have 4 plus 8, you have 12 factorial. So if I arrange everything without condition, right? Without condition, it will be divided by 2 factorial, 2 factorial, 2 factorial, 2 factorial, right? If we divide everything. So, and inside this arrangement, this is all the arrangement without condition, means that it's the biggest way, okay? It's the largest possibility, all right? That you can arrange all the alphabet letter here without condition. So then, and have to minus, right? I have to minus away the possibility that because they said the two letters E are separated, so I can minus away the ways, the arrangement at which the two letter E's are together, right? If I take all the possibility minus away, subtract the arrangement at which the two E are together, then the remaining one will be the arrangement where the E are separated. Alright, so how to consider that? So let's see how I want to consider that. So what happens if the two E must together, right? Means that if I have arrangement, okay, arrangement, so ARNG, okay, MNTS with the E must always together. Means that what is meaning by the E is always together, means that arrange always together. So means that now we have supposed to have 12 factorial, right? Because of the two E must always stick together. So means that I assume it to be a E. Alright? So now means that I assume this to be a single E, right? Because they always must move together, right? They must move together. And alright, and I need to minus away, right? Now I still have how many alphabet, right? Now you see, because the E must move together, right? They must move together, so the E won't be separated, right? So means that if they must move together, I assume that as one object, right? One same object. So, and total now you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? 12 alphabet become 11 alphabet to be arranged. But among the 11 alphabet here, I have, okay, because the E must be together, right, must together, so I no longer need to divide by 2 factorial, right, because I assume they are EE, they are just a letter E, right, and some more, these two are identical, right, they are identical, so if they are different, then different calculation. Now they are identical, right? So I don't need to divide by 2 factorial because they move together. Either the E here or the E is here, it still will be the same. So I just need to divide by 2 factorial. 2n, 2r, 2a, 2n, 2r, 2a. And don't need to divide it by 2 factorial for the E, okay, for letters E, because they already fixed, they already together, right? And this 2 is identical, right? So then with this calculation, you will get the number of ways of the 2 letters E are separated. All right, the result you were getting 2494. 8,000. Alright, 8,000. Okay, I repeat again. Why I don't divide by the 2 factorial here, right? By 2 factorial here. Because I already assume this is actually 11 object. 11 different object. Means that 11 factorial means that these 2 E, I already assume them as one single E, right? Because they must move together. And that's why we have 11 factorial. So that's why I no longer divide by the 2 factorial that included E, right? So I just divided by these 2 repeated 2 factorial, 2 factorial. This is the arrangement where the 2 E are together. When we minus all the possibility with the 2 E are together, the remaining one, this will be the arrangement where the 2 E are separated, right? So that's all for part B, and let's move on with part C. Alright, let's look at part C. I think you're able to do part C if you already know how to do part B. the two letter E's and the two letter A's are together. Means that the two letter E's and the two letter A's are together means that it's something like this, where the E, right, are together. So means that the remaining one will be RR, right, RR, and NN, GMTS, right, GMTS. Only these four must together. The two letter E and the two letter A must together, right, are together. So means that they are grouped together, right. So this among themselves they can be arranged. Yeah, even the AAEE can be inserted in between. AAEE, RN, GMTS, or the AAEE can be arranged here. And among these also can be arranged, right? Because this, I assume this as one object now. Now I assume this as one object now, right? The two letter E's and the two letter A's are together. So means I assume them as one object. Alright, so where's the two letter A and the two letter E are together. So now, at first we assume that this will be, this one will be one object. Alright, will be one because they must move together. So total you have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 factorial. Okay, I said this to be 9 factorial because 1, right, this assumed as 1. So 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 factorial. And I divide by, now I consider this as another alphabet. Okay, I put it as star, alright? This, everything here, I put it as a star arranged together with all this. So 9 factorial divided by 2 factorial because only this 2 is repeated, right? RR and NN, right? So it means that 2 factorial over with 2 factorial because you have 2R and 2N and this 2R and 2N. So, but this is slightly different because why? Because this whole thing, let's say if all is A, then this will be your answer, right? This will be your answer. But because of among AAEE, even though they are together, actually they are can be rearranged among themselves. It can be AE or EA, right? Can be anyway. So, but okay, we assume that this is a one object, a star. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 factorial divided by 2 factorial, 2 factorial. Alright, we assume this as another one. But among inside here, there are 2 different alphabet, right? So I need to multiply with 4 factorial because inside here is another word, right? We arrange them 4 factorial divided by 2 factorial, 2 factorial, right? We divide by 2 factorial and 2 factorial because this is 2 repeated, 2 repeated. We assume that as 4 different objects, 4 factorial. Then I taking the 4 factorial divided by the 2A and the 2 repeated E, right? So now this will be my calculation. Okay, let's see how many ways. Alright, which we're giving you 5, 4, 4, 3, 2, 0 ways, right? 5, 4, 4, 3, 2, 0 ways. Alright, let's move on with the next question. Alright, for part D, the arrangement where the consonant letters GMTS are together, right? So the consonant letters, so beside AR there is another 4 distinct alphabet which is GMTS, right? Total up of 12 different 12 objects, alright, which have repeat. A, R, E, and N is repeat. So for part D, right, the consonants letter GMTS are together. Means this must move together, right? If they are together, means that the G, M, and S, I can say that A, R, R, A, N, right? E, N. So and GMTS must together, right? I group them together. Right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? 12. So now, this can be anyway. So, and this must be together. They must together. So when they are together, I always said, I assume that as one object. I don't know how to represent this. I just put a star. Alright, they must be together. So when they are together, it's just like, okay, I replace this whole thing with star, right? Means it's another alphabet. So means now we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 alphabet, right? So we arrange 9 factorial. Why? Because now we just assume this is the same, alright? This is the same because they move together, right? So 9 factorial. So the repeat one will be 2a, right? This is all the consonant 2a, 2r, 2e, 2n. So you have 2 factorial, 2 factorial, 2 factorial, and 2 factorial. But is this enough? If you know how to do C, you know how to do D. Is this enough? This is just assume that this is as one object, right? Factorial. So then all of them together is 9 factorial. But because there is a repeat, I divide by 2a repeat, 2r, 2e, and 2n, right? The arrangement of each of these. And is this enough? No. Because why? If all of these letters are of the same, for example, G, 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 all is G, then we say, yes, this is enough. But now the case is, this is 4 distinct objects. They are different, right? So I need to multiply, even though they are moving together, but among themselves, they can be rearranged, right? So I should multiply with another 4 factorial, right? I should multiply with another 4 factorial. So let's see what's the answer. Right? Which we're giving you 5, 4, 4, 3, 2, 0 ways. Right? 5, 4, 4, 3, 2, 0 ways. So by now, I hope you already understand how to do with this type of problem here. Alright, let's go for the last question. Alright, okay, let's look at the final item here, E. The 2 letters N occupy both ends, right? The 2 letter N occupy both ends. So it's not very difficult because you know that you have 12 alphabets, right? You have 12 alphabets, so 12 alphabets. The 2N must occupy both ends, right? Fixed means that the N is already must be occupied both ends, right? So means that it's become the remaining 10 factorial only. Why? 10 alphabet, right? You have 10 alphabet to arrange for the middle one. So the 10 factorial, among the remaining 10 factorial, we have 2a, 2r, and 2e. That's all. Very simple. We just divide by 2 factorial, 2 factorial, 2 factorial. So this will be the numbers of ways of arrange with the both end occupied both ends. Alright, giving you the answer will be 4, 5, 3, 6, 0, 0 ways. Right, I think that's all for these problems. Hope you understand